下一位为我们带来主旨演讲的嘉宾是 Jaime Yassif 博士。Jaime Yassif，核威胁倡议组织全球生物政策与项目副总裁，致力于降低灾难性生物风险，加强生物安全和全球健康安全，在科学技术、公共卫生与国际安全交叉领域拥有超过20年的政府与民间工作经验，拥有加州大学伯克利分校生物物理学博士学位。Dr. Yassif, I will hand it over to you. Welcome.
Great. Well, thank you so much to the organizers and to all of you for joining today's discussions. Really delighted to be part of these really important discussions about AI safety. I'm going to be talking about the convergence of artificial intelligence in the life sciences, and specifically steps that we can take together to safeguard these capabilities. So when we say AI biocapabilities, it is the broad suite of tools at the nexus of the life sciences and artificial intelligence that enable engineering of living systems. So for the next few minutes, I think there are some formatting issues, but you can bear with me. For the next few minutes, I'm going to talk about 3 topics. What are the steps we can take to safeguard AI biocapabilities? What are some of the technical guardrails we can put in place? And some work internationally to share best practices for these kinds of safeguards. So first of all, what is the problem we're trying to solve? What are the risks we see? So as we've heard from many colleagues, there are tremendous potential societal benefits from AI biocapabilities, including accelerating vaccine development, improving public health and medicine, and driving economic development, including through development of the bioeconomy. At the same time, these same capabilities can also increase dual-use risks. And the 3 kinds of risks that we've been focused on are lowering barriers to malicious actors causing harm with biology. This risk is already here today, and that's well documented, and it's especially there's a lot of documentation that large language models are lowering barriers to access. In the near term, with uncertain time horizons, we're also seeing the ability of AI to increase the level of harm that a malicious actor can cause with biology, including engineering more dangerous pathogens in nature. And finally, the third risk is thinking about ways that these kinds of capabilities can reduce the effectiveness of biodefense measures like disease detection, vaccine development, or existing biosecurity measures like DNA synthesis screening. And in fact, in order to raise awareness about these important risks among policymakers who are still trying to keep up with the rapid pace of change, we created a statement on biosecurity risks at the convergence of AI and the life sciences. We got more than 35 leading experts from across the globe to sign on to this statement, to call on governments, model developers, and funders to prioritize safety when advancing these models. The signatories include Yoshua Bengio, Helen Clark, who's the former Prime Minister of New Zealand, Andrew Yao, Wei Wenjiang, Brian Si, as well as George Church, who's one of the leading founders of the synthetic biology community, and many others. In terms of actions we should take to address these risks, there are a number of recommendations that NTI has made. One is that governments and private funders should invest in developing guardrails for biological AI tools and other AI biocapabilities, and that we should be very broad and strategic and comprehensive about this. We should follow a research agenda. We've heard about the need to invest in research and development for mitigations. It's true in AI bio as well. Second, we would like model developers to prioritize responsible development and deployment of AI bio tools, so that includes both within industry and academia. Funders have an important role to play when they're evaluating proposals. What work do they fund or not fund? Biosafety and biosecurity should be a requirement. And that as best practices are developed, governments should incentivize them through guidelines, regulations, and financial incentives. The good news is that there's already a lot of public discussion among model developers about the importance of responsibility. You see some of the leading AI labs here, both in academia and in industry, are talking publicly about safety and security from a bio perspective. We started this work at NTI in 2023 when we launched our report on the convergence of artificial intelligence in the life sciences, and we were really looking to answer 3 questions. One is, what are the capabilities that we see now and that we anticipate on the horizon for the convergence of AI in the life sciences? Second, what does this mean for biosecurity? What are the opportunities and what are the risks? And third, what do we do about it? What are the governance opportunities that we can explore to reduce these risks? And the types of AI models that are relevant to the AI biospace, they're generally in 3 large buckets. There's large language models, which I think are mostly familiar to the public. And then there's AI biodesign tools, which are more specifically trained on biological data and perform more narrow specific biological functions and are distinct. And then there's automated science, which is a capability that's advancing rapidly on the horizon. Our recommendations really fell into 3 buckets. One was on governance at the national and international level for AI bio capabilities. One is developing a new research agenda for AI bio guardrails. It's very early days and most of the work is ahead of us for developing mitigations. And then the third one is really using the benefits of AI for strengthening biosecurity and for building more robust pandemic preparedness capabilities. For the next few minutes, I'm going to talk about 2 specific recommendations that we followed up on. One is creating an international forum to address AI bio risks, and one is pursuing an ambitious research agenda. So we took our own advice, and we met in Cambridge in 2024 to talk about what a research agenda could look like. We drafted a paper trying to map out the broad range of possibilities and hypotheses we should explore for safeguarding AI bio capabilities. It's public and online, and we're continuing to update it with input from experts. It includes both for large language, includes ideas for intervention opportunities, both for large language models and biological design tools. We need to update it to think about automated science. In terms of the technical guardrails, this is a map sort of the research agenda specifically for safeguarding biological design tools. There's been a lot of work and talk about mitigations for large language models, but for biological design tools, there's almost nothing that's been developed or deployed, and so we have a lot of work ahead of us. The key takeaway from this slide is that there are many different things we can try. We don't yet know what's going to work and what's going to be effective and feasible, but it's throughout the life cycle of developing and deploying models. We are pursuing a couple pilot projects at NTI to explore parts of this research agenda. One is an idea of coupling designs with metadata, and to basically try to solve this problem that if a DNA synthesis provider, people who print DNA for scientists around the world, if they get an exotic design that was designed by a series of AI models, they don't know how to interpret it because they can't match it to an existing sequence that you can find in a public database. And so if you can sort of couple metadata with the design when it's sent to the DNA synthesis provider or some other service provider, they can interpret it and do a better job of doing risk assessment. So we have a pilot project with Lattice Automation for that. The other pilot project we have is one on managed access, and this is a really fundamental question about safeguarding AI bio capabilities, because our hypothesis is without managed access, it's very hard to have robust safeguards in place. And so right now we're doing a series of interviews led by my colleague Sarah Carter, who's talking to the scientific community about what is the right approach here. But fundamentally, we think that this is can be compatible with equitable access and access to these tools, because we understand that the benefits of these tools depends on access, and we think that tiered frameworks will be essential. Many of the tools in this space are low risk and don't need to be behind some sort of API, but there are tools with higher risk and there should be tiered access. Here's a really quick snapshot of what tiered access could look like. This is published in our report from 2024 on guardrails for biological design tools. Basically, the takeaway here is it's not black or white, either closed source or open source. There's a range of options between that we can think about. My last point will be about the AIxBio Global Forum. And so as we've heard from other colleagues, the solutions here are both technical and from a policymaker perspective. And so this is not a problem we can solve in individual nations. It's a global problem and it's going to require a global solution. And that's what motivated us to establish the AIxBio Global Forum. And we have 3 goals with this. One is developing a shared understanding of risks. One is supporting the development and sharing of best practices to mitigate risks. And over time, as we develop recommendations, providing those to policymakers and others so we can drive adoption of best practices for biosecurity. It was established in 2024. We've been consistently convening. We're eventually going to spin this off as an independent entity. It's very international, and there are a number of members from China who are here with us that participate in the forum. And the first activity of the forum was this high-level statement on risk that I was talking about. So thank you so much for your attention, and I'm looking forward to the discussion.
Thank you, Dr. Yassif. Please take a seat.